Okay, this is the tutorial for the testing the warning system design in Amplify. So before we begin, you need to make sure that you've got some supplies. Number one, make sure that you have your sensor analysis worksheet. And I asked everybody to take a picture of the map of the Indian Ocean region that Futura supplied to us. The one that I have here doesn't have the markings on it. So you need to have that because you need to find out where the convergent plate boundaries are, since we know that's where tsunamis are generated, at convergent plate boundaries. It's not going to do you any good to place sensors at or near divergent plate boundaries. It's just a waste of time and money. And then you also need to have your data sheet. If you do not have a blue data sheet that I gave you in class, then you need to go to today's folder, which is uh, Tuesday, November 14th, that has a digital copy of the data sheet. And you can use that, put that in Good Notes, and you can use that as well. Okay, I'm going to need you to go into your design warning system in Futura. You can go into the Futura workspace right here, go through the steps and do all of that, or there's a shortcut. If you can find your waffle icon up here for programs and apps, if you click that, then you can go immediately over here to the Futura workspace. Mine might look a little bit different than yours since I'm the teacher and that's my teacher view. But once you get into the Futura workspace, pick your purple icon, and then you're going to go in. It's in the top right corner. It's the triangle with the wave, and you're just going to click that. Okay. All right. I'm going to get out of here, and I already have my sensors filled in. So this is what I did. Remember, in order to place your sensors, you're going to grab one and just move it over to where you want. But before you start placing your sensors, you need to come up with a plan. So what we did is we've got a plan. It's my hypothesis. It's what I wanted to test. Now, everybody in class should have followed my example and copied this one. Your plan is going to be whatever you want to test. Okay, so make sure that you put your version number, so it won't be one, it's going to be 2 or 3 or 4 or however many tests this is for you. And then just in a simple explanation, tell me what you want to do and what you think it's going to do. Okay, um, so I'm going to use one of each type of sensor in order to keep the cost low. All right, so I went ahead and I placed my sensors at K8 for the earthquake and the my earthquake and my shallow sensor. The earthquake, I have it on the tip of this piece of land here, and then the shallow sensor is in the shallow water, and then I put a deep sensor right here at K11. You want to make sure before you hit test, make sure that you fill this out. So in your build, you're going to tell me exactly what we did to test the idea. However many sensors you choose to use. So I just used one of each. And then make sure that you place your coordinates here. Eventually, you're going to take a picture of each part of this data plan, and you're going to use that in your presentation. So it is very important that you have this accurate. I want to be able to go back, put my sensors there, and get exactly what you got. And then don't forget here, the earthquake mode is just automatically set to random. So go ahead and make sure that you color that in. If I wanted to change the earthquake mode, I'm going to go up here in the top left, and this is where I can change it. But it just defaults to random, and let's just keep it there until you are ready to fine tune your plan. And then once I do that, I'm going to hit the test button, and I'm going to actually hit this again. You're going to notice that it's a random earthquake, right? But you're going to end up getting, if you don't change anything and you just keep hitting test, over and over again, you get a couple different scenarios. And I want the one that has the C3 earthquake in there. So I think that's it. I'm going to keep this one. Oop, actually, I'm going to go back and do one more. Yep, this is the one I want. Nope, that's not the one I want. Sorry, you guys. Yep, this is the one I want. Okay, so I'm going to come back here. And I am looking at my information for what I got with my tsunami alert. It tells me this is my design overview. These are my test results. You're going to copy your test results, which I have right here. You're actually going to copy them into your test, um, your square there on your data sheet. You're just going to copy everything over, just move it over. So my average warning time was 0 minutes. Not all of the necessary warnings were received. There were 2 false alarms, and my total cost over the year is $28,854,000. The next thing we want to do is we want to analyze this. So I always want you to put a plus for anything that was good and a negative for things that were not great. Sometimes you might have all pluses, but it's just not the best. Sometimes you're going to have all zeros. You have nothing good that came from it. The important thing is that we analyze. Remember, the definition of analyze is to look at something closely for the purpose of, or for a specific purpose. So we're looking at this. It's not something I can look at really quickly. I have to really, really examine it. I need to know why. This was a good cost for over 50 years. My hypothesis was if I use these 3 sensors, then I'm going to get a low cost. I don't know if it's a low cost. This is my first one. So it's, $500,000 every year for 50 years. Seems like it's okay, but I don't really have anything else to go on. So for right now, I'm going to say it's good cost. Not great, good. My warning times are horrible, and I have 2 false alarms. That's not good. So we got to ask ourselves why. This is the analyze part. So if I go back into my tsunami alert, I'm going to look up here where it says study earthquakes. So I'm going to come back. I'm going to click on study earthquakes. And over here on the left, we have an image of that shows where all of those red dots are. These are all the earthquakes that occurred in the area over the past however many years. I know that in order to generate a tsunami, earthquakes have to have a magnitude greater than 7. So all of these over here that are 6.9, I don't even want to look at those. So I'm going to toggle that show off, and it removes them here from my map. So now I'm left with magnitude of 7 to 8 or greater than 8. I know not all magnitude 7s will cause an earthquake or cause a tsunami. I also know that not all of them are going to generate ocean-wide tsunamis. And so I have to click on every single one and get information from each one. So as I do that, I can see if I click on an earthquake and I don't see any waves, that means that one didn't generate a tsunami. I'm going to look at the next one. This one generated a tsunami, but it was a local tsunami. So in other words, it didn't get to Sri Lanka. It also did not touch my sensors, so no false alarms were given on this one. This is good information for me. I want to maybe stay away from this area right here, possibly. Okay, so this one didn't generate a tsunami. G10 didn't generate a tsunami. And I'm going to scoot over here. E4 also generated a tsunami, but it was just local. So this is good information for me to have. Now I'm looking at L9 and L10, and I have a lot of information here. I want to break it down for you. First of all, this is a magnitude 7.7. It did not generate an ocean-wide tsunami. And so once it hit, look at, I can use this wave animation over here, and I can back it up, and I can see exactly what happens when that wave touches my shallow and my my earthquake. So what happened was the the data got sent. I know one of these is not a great one. I can't remember what it is, so you'll have to look on your page, on your information page. But one of them is not super reliable. So it waits until there's another sensor that has gone off. And then they'll say, okay, yeah, this is a tsunami. Well, they sent that, the data was sent to Sri Lanka, but because it was just a local tsunami, that counts as a false alarm. Okay, that's good information. Also, I can see that my sensor broke. If I click on each one of these tabs, it will tell me exactly what happened. So this earthquake had 7 detections in 50 years, and it had 1 false alarm, 0 breaks. In 50 years, the shallow had 4 detections, 1 false alarm, and 3 breaks. Now, I know the shallow is not my most expensive one, but when I have 3 breaks, that's going to increase my cost. So that tells me right there that that 50-year cost is really higher than what it needs to be. So I know I can actually bring that down. So I'm going to take this information. I'm going to go back to my study earthquakes. I'm going to look at L10. So here we have another local tsunami. None of these are really anything that I need to have sensors near. So that's really good information. Do I have any earthquakes over here that caused a tsunami in Sri Lanka? So let's take a look at those. K8 sure did. Now, unfortunately, we had 0 warning time. That's no bueno. Let's back it up and see what happened. What happened was immediately my sensor broke. Data was sent, but because the sensors broke, I mean, there wasn't, if my shallow sensor breaks, that's the one I believe that needs to have a second sensor go off. And so it didn't. And so Sri Lanka, they just didn't have enough time. I'm going to look at that data for my shallow. I had 3 breaks, 1 false alarm. Okay, this is a problem. Let me come back and look at the rest of these. K7, there we go. We had data sent, no breaks. This was a magnitude 9.1. This was huge. So what I can see is by the time that wave actually hits my sensors, it's just too late for Sri Lanka. It's too late. So there's good information here, and maybe I need to have sensors in this area, but where I have them is not right. I need to consider moving them. If I look at K8, here's another one. The data was sent, everything was great, but it just got sent too late. If you remember, the deep sensors are the most reliable. And look what happens. By the time the wave gets to the deep sensor, it's already past Sri Lanka. So that's not doing them any good. I need to maybe think about moving that deep sensor. Lastly, I'm going to look at this one, C3. This is a magnitude 8.2. It absolutely hits Sri Lanka, and I don't have any sensors in that area. I got to consider maybe moving some sensors there. So what you have to do then is come back to your analyze. Everything that you've just seen, it's common human nature for us just to look at it and want to fix it and just move on. I need you to really put down on paper what you saw. This is the analyze part. So I divided mine up into those 3 sections or those 3 groups. The earthquakes that did not generate tsunamis, the earthquakes that generated local tsunamis, which means false alarms, and then tsunamis that did reach Sri Lanka. And then I was able to identify maybe the sensors broke, the deep sensor was too far, or in that one area with C3, I didn't have any sensors at all. This is where my idea for the next plan comes from. Okay, so just pick one thing that I want to fix and then write that on your plan. So my next plan, remember you're going to put version 2, or for you now, version 3 or 4, or wherever you're at. What's the idea that I want to test? Well, I want to try to move my deep sensor to the C3 area. And since I had so many breaks and like false alarms, and I know I need sensors over there, but I just don't know what to do with them yet, I'm going to actually delete the other sensors. My hope is, let me kind of dial in and just do one sensor at a time. And then maybe I'm able to really come up with a great plan without adding sensors that I don't need. Okay, I hope this was beneficial for you. Let me know if you have any questions.